Myself, DEVDAS, Assistant Professor of Care Engineering College in CSC department. So today my topic is design and analysis of algorithm in the third BTech first semester. So design and analysis of algorithm. Why study this subject? First, efficient algorithm lead to efficient programs. Efficient programs sell better. Efficient programs make better use of hardware. Programmers who write efficient programs are preferred. So, what able to student course outcome after completion the course, students should be able to these five course outcomes. First one is CO1 to analyze performance algorithm. CO2 to choose the appropriate data structures and algorithm design method for specified application. To understand CO3 to understand how the choice of data structures and algorithm design method impact the performance program. CO4 to solve the problem using algorithm design method such as greedy method, divide and conquer, dynamic programming, backtracking, and branch and bound. CO5 to understand the difference between tractable, intractable problems in introduce P and NP classes. So, design and analysis of algorithm. First, what is the algorithm? First, you understand the algorithm. First introduction right now, the introduction algorithm definition. So, there is algorithm specification, performance analysis, space complexity, time complexity. So, what is an algorithm? An algorithm is a list of steps, sequence of unambiguous instruction for solving problem that transforms the input into the output. So, problem, first we have to rectify the problem and the algorithm. After that, the input to output. So input, we have to take the computer, then we have to output. So what is the algorithm definition? Algorithm has come to refer to method that can be used to computer for the solution of the problem. So an algorithm is a finite set of instructions that accomplishes a particular task. All algorithm must satisfy the following criteria. So the following criteria means there are five criteria there. So first one is the input. Second one is the output. Third one dependence. Fourth one finiteness. Fifth one effectiveness. So what is the input? So input means zero or more quantities are externally supplied. What is the output? At least one quantity is produced. What is the definedness? Each instruction is clear and unambiguous of the algorithm. Example, suppose statements such that you are add 6 or 7 to x or compute 5 by 0 are not permitted. Finiteness. So if you trace out the instructions of an algorithm for all cases, then the algorithm should terminate after a finite number of steps. What is the effectiveness? Effectiveness means the instructions is basics enough to be carried out. So, properties of an algorithm. We are seeing that an algorithm takes zero or more input. An algorithm result is one or more outputs. All operation can carried out in the finite amount of time. An algorithm should be efficient and flexible. It should it should use less memory space as much as possible. An algorithm must terminate after finite number of steps. Each steps in the algorithm must be easily understand some reading point. An algorithm should be concise and compact to facilitate verification, there the correctness. So, algorithm specification. Step one, identifying the number. So each algorithm is assigned and identify the number. Example, algorithm one, algorithm two, etc. So we have to identify algorithm name. The second one is the comment. Each step may contain comment brackets which identifies the indicate the main purpose of the step. So double colon is we have to comment. The comment will be used to appear at the beginning or ending of the steps. It usually indicates with two square brackets. So example, step one, initialize. So initialize, we have to two square brackets. The set k equals 1. Next, step 3, the variable names. It use the capital letters, example, max, data, single letters, names of variables used to counter of subscripts. Step 4, the assignment statement. It uses the dot equal notation. Some text use arrow mark, left mark, and equal notation. Step 5, input and output. So data may be input assigned to variable by means of a read statement. It is syntax. The read equal variable names. Example, read the variable name, suppose ABC, XYZ. Similarly, message placed in the quotation marks. The data in variable may be output by means of write or print statement in syntaxes. The write message are variable names. Example, write means write dot a comma b comma c. Here a comma b comma c is the variable. The step 7, the controlling of the, there are three statements. It has three types. There are sequence logic and selection or and step single alternative, double alternative, multiple alternative. First, the controls sequence logic. It is executed by means the numbered steps are by the order in which the modules are written. Second one is selection or conditional logic. It is used to select only one of several alternative modules. The end of structures is usually indicated by the statement. End of if structure. The selection logic consists of three types: single alternative, double alternative, and multiple alternative. Here, single alternative, if the syntax is if condition, then the end of the if structure. The double alternative, if condition, then else, after that, end of structure. The multiple alternative means there are if condition, there are two or more conditions there. So here, see that if condition 1, the else if condition 1, else if condition 2, else if condition m, then the model end. Here the end of the structures. The algorithm, we have to use the real-time application. We have hardware design, VLSI chips, compilers, computer graphics, movies, video games, routing messages in the internet, searching the web, the distributed file sharing, computer-aided design and manufacturing, security, e-commerce voting machine, multimedia, CD player, DVD, MP3, JPG, HDDV, and DNA sequencing, protein folding, and many more. These algorithm, you can use the real-time application. The algorithm design techniques, there are brute force, exhaustive search technique, and divide and conquer technique, transformation technique, dynamic programming, and greedy method, and iterative improvement, randomization. So what the next topic is algorithm is performance analysis. There are many criteria upon which have to judge an algorithm like That is the program efficiency use primary and secondary storage, right? So is program running time acceptable for this task? Does it do what we want to do? Is the program is code readable or not? These are valid when writing the program, but our intention is the judging and algorithm that have more direct relationship to performance, so that calculated is the space complexity and time complexity. So what is the space complexity? The amount of memory needed to run an algorithm is called space complexity. So the space required by the algorithm has the following component. There are three types. One is the instruction space, data space, environment stack space. So instruction space is the space is needed to store the compiled version of the program instruction. The amount of instruction space that is needed depend on the compiler used to compile the program into the machine code. Data space. So data space is the space needed to store all the constant and variables values. Data space has two components, space needed to constant and variable. The space needed by dynamically allocate objects such as array or class instance. Environment state place. The environment state place is used to save the information to resume execution of partially completed function. Each time function is invoked, the following data saved and the start. The return address. The value of the local variables and formal parameter into function being invoked. So, what is the environment stack space? Suppose the real-time scenario, we have to check, suppose you have to online service, you go to the Amazon. So you are buying the any electronic device. So first to choose that electronic, after we have what is the chosen suppose you are choosing the dress, anything. So we have to choose what you choose. The next time also you have to appear this time. This is called the environment stack space. Right? Right? The size of the instruction space is independent of the problem instance to solve. The contribution of constant and similarly variable to the data space is also independent of the problem instance to be solved. The most of the dynamic allocated memory, example arrays, class instance, depend on the problem instance to be solved. The environmental stack space is generally dependent of the problem instance unless recursive functions are in use. So here, see that the recursive function means the self-recurrence of the algorithm. So here, recursive algorithm, so R factorial, here double colon comment if n is an integer, if n equal to 1 or n equal to 0, return 1, else return n fact n star r factorial n minus 1 close bracket. So here, each time the recursive function r factorial is invoked, the current values of n and fact the program location to return to an completion and saved in the environment stacks, right? Because we have written only one time, but the all time you saved to environment stack place. Therefore, we can divide the total space needed by the program into two parts. First one is the fixed space requirement, variable space requirement. The fixed space requirement independent of the characteristics of the problem instance. I. So instruction space and space for simple variable are constant. The second one is the variable space requirement, SPI. So depend on characteristics on the problem instance. So number of input and output associated with I. The recursive stack space, the formal parameter local variable return address. So therefore, the space required of any problem P can be written SP equal C constant plus SP instant characteristic. So for variable, some operations 1 word space occupied, for loop n word size occupied. Here example, int square into a open bracket return a into a close bracket. Therefore, s square instance character 6 1 because here only into variable only one character 6. So because the space complexity is 1. The second example here that algorithm sum a comma n open bracket s equals 0 for I equals 1 to n do s equals s plus ai return s close bracket. See that here statement particular statement is value is 1. For any loop value is n. So here for I equals 1 to n do here n plus s equals 0 one statement and s is equal to s plus ai is a one statement. The return s this also one statement. So here n plus 1 plus 1 n plus 3. Here the space complexity is n plus 3. Next, time complexity. The time complexity of an algorithm is the amount of computer time it needed to run to completion. TP equals C plus TPI, right? So the time TP taken by a program, P is sum of its compile time C and its RAM execution time is TPI. The compile time does not depend on the instance characteristics. We will concentrate estimating runtime TPI. See that as these were some problems is determining the execution time using earlier method, we will go and step further and count only the number of program steps. Here program steps is loosely defined as the syntactically and semantically meaningful program segment whose execution time is independent of the instance characteristics. Right? The number of steps assigned to any program statement depend on the kind of statement as I. Here comment are counted as 0 number of steps. An assignment statement which does not involve any calls to other functions counted as 1 step. For loops such as for, while, and repeat until we consider the step only for the control part of the statement. So here see that tabular method. Example, iterative sum of n numbers. So here algorithm n numbers, algorithm sum equal to a comma n, open bracket, s is equal to 0. For I equal to 1 to n, s equal s plus array of I, return s, close bracket. So here frequency and total steps. These are the tabular method form, right? Here algorithm sum with the frequency, there is no frequency, so dash. The open bracket dash. So s is equal to 0. The statement 1 is right. So here 1. For I equal to 1 to n. 1 to n means the here statement 1. So n plus 1. Here another statement s equals s plus of I. So here n. So return s. Here also one of the statements. So here 1. The frequency counted and total steps. Here dash marks equal 0 and dash equal 0. Here frequency 1 to 1, n plus 1. Here also n plus 1, n equal n, 1 comma 1. Here the open bracket equal dash. So here 0. So these total count 2n plus 3. Right? You understood? Next example, addition of two matrix multiplication. Here, see that algorithm add a comma b comma c m comma n. Here a comma b comma c is the variable, m comma n is the two matrix, right? So for loop I equals 1 to m, one matrix. For loop j equals 1 to n, second matrix. So these two matrix we have to adding. Adding means c of I comma j equals a of I comma j plus b of I comma j. Here see that. So algorithm adding, there is no frequency, so you can do it the dash. Open bracket, we also do it the dash. The for loop m plus 1. The for loop already m plus 1, we have add matrix multiplication, right? So we have to j equals 1 to m into n plus 1. So these two matrix multiplication is right. So m into n. This is the frequency. The total steps here dash marks is 0. Here dash marks is 0. M plus 1 also here m plus 1. M into n plus 1 here. This is the expansion. Mn plus m. Here mn, here also mn, here 0. These are the 2mn plus 2m plus 1. This is the addition of two matrix multiplication. We have to time complexity. So this topic is covered only what is the algorithm, what is the performance analysis of algorithm. These two topics covered in the design and analysis of algorithm. Thank you.